Gentlemen, this is Newton's laws of motion and correlates with chapter 10.3 in your textbook. Your key concepts for this video are: who is Sir Isaac Newton, and what are Newton's 3 laws of motion? So let's first talk about Sir Isaac Newton. You've heard his name a lot in different science classes over the years, but let's talk about how he became this person we all talk about. So he was born in England, and he was a premature baby. He was also born to a single mother because his father had died 3 months before he was born, so he never knew his dad. His mom, after trying to be a single mom for a while, gave him to his grandparents to raise, and she went and remarried. In his teens, his mom came back into his life and started working for him to become a farmer. But Sir Isaac Newton kind of found farming a little boring, and his uncle saw his academic potential and his scientific curiosity, so he convinced her to let him go study at university. When he was at university, initially, he kind of just did average. But it wasn't because he wasn't doing things. On his own time, instead of studying for the classes he was taking more advanced material and studying it and writing notes and having questions and trying to figure out more advanced material. And later in his life, he had a huge rivalry with Robert Hooke. Robert Hooke, if you remember back to 7th grade, is the guy who first described cells and saw that sample of cork. But Robert Hooke and Isaac Newton, they were not friends at all. One of Newton's biggest pieces of work is the Mathematical Principles of Natural Philosophy, which is sometimes shortened to Principia. He published it in 1687, and it stated the law of universal gravitation, everything with mass has gravity, and his 3 laws of motion. And many people, if you have to ask them what is the most influential book in physics, will say that his book that he published is huge. It completely changed the way we think about physics. So let's examine these 3 laws of motion. The first law of motion is an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an unbalanced force. So if something's moving, it's going to keep moving, and if something's still, it's going to stay still until another force acts upon it. This is also sometimes called the law of inertia. You might remember that word from the beginning of all the Bill Nye videos. So inertia is simply the resistance to change of motion. So this is why you can do this tablecloth trick where you have all the tables and you pull the tablecloth out really fast and everything stays. It's because those objects have inertia and they resist that change in motion. Or while with a car, it's really hard to push it at first, but once it gets rolling, it's pretty easy to do. That's also because of inertia. It's hard to get it moving, but once it's moving, it wants to keep moving. And inertia depends on the mass of an object. So on to Newton's second law. Newton's second law of motion is that an object's acceleration depends on its mass and the net force acting upon it. So here, this mass is relatively low because it's empty, and the net force acting on it is relatively low, so it's got a low acceleration. Whereas here, the acceleration might be the same, but the mass is much, much bigger because that little person's sitting in there, and this guy's having to work really hard with a huge force on it to get it to accelerate at all. And we can actually represent this in a mathematical formula. We show force, F, equals mass times acceleration. And just like speed, there's a handy-dandy little triangle to help us figure this out. So if I want to know force, I cover force and I do mass times acceleration. If I want to know the mass of something, and I have the force and acceleration, I do force divided by acceleration. And if I want to know the acceleration of something, and I have the force and mass, I can do force divided by mass. Let's talk about his 3rd law of motion. This is the last one. For every action, there is an equal and opposite reaction. This is where you get action-reaction pairs. So here, when he's pulling on the wall, the wall is pulling back with a force of 500 newtons, which is the same as if a person or an elephant was standing there and pulling back with that force of 500 newtons. So every action has an equal opposite reaction. You can also remember those Newton's cradles that we were playing with. You pulled back one ball, and the other one popped right out there. If you pulled back two popped out on the other side. If you pulled it back really far, it went out really far on the other side. So all of that is Newton's 3rd law of motion. That's it. Be sure your notes hit all the key concepts and vocabulary, and feel free to try this challenge question.